We continue learning workbook page 180 with a few more problems involving graphing exponential functions. We are using the plot the points and connect the points method as specified in Alex. Graph the exponential function f of x equals -1/4 times 4 to the x power. To graph the function, plot the points on the graph with x values -2, -1, 0, 1, and 2. Next, draw the asymptotes, if any, and then click on the graph button. Okay, let's proceed. So this is actually a pretty simple idea. We know that f of x is the same thing as y, so our equation is -1/4 times 4 to the x power. Now the first question that I want to ask you, and the first question that you should ask yourself when you see a problem of this type, is what's the base? So I'll ask you the question, answer it on your own. What's the base? Now, if you said that the base is -1/4 times 4, that's incorrect. But if you said that the base was 4, that's correct. And the reason why is exponents happen before multiplication, and exponents only affect the base. If we wanted the -1/4 to be part of our base, then that -4 would have to be included in parentheses with the 4. Absent those parentheses, that means that our base is just this 4. All right, now, here's why that's important. We're now going to plug in all of the values of x listed here to get some points for eventually for us to create our graph. All right, so let's begin. So we want -2, -1, 0, 1, and 2. Let's start with the first value. If x equals -2, then y equals -1/4 times 4 to the -2 power. All right, so this is where knowing the base is going to be very, very helpful. Only the 4 is affected by this -2. So we're going to focus on the 4 to the -2 power first, and then do the things that are around it. Well, using our knowledge of exponent rules, we know that 4 to the -2 is the same thing as 1/4 to the +2. So we get -1/4 times 1/16, and we multiply the fractions by multiplying across. 1 times 1 is 1. 4 times 16 is 64, and then the negative makes it negative. So we get -1/64 as our point here. You can tell Alex that you want to put your point at that location. You just have to select the icon that allows you to specify by typing the location of the ordered pair when you put it into the software. All right, let's move on to the next one. If x equals -1, then y equals -1/4 times 4 to the -1 power, which is -1/4 times 1/4 to the first power. Of course, 4 to the first power is just 4. And then multiply the fractions, and you get -1/16. -1/16. All right, next one. If x equals 0, then y equals -1/4 times 4 to the 0 power. Well, just as before, we're going to work on our exponents first. 4 to the 0 power is just 1, so I get -1/4 times 1. Anything times 1 is itself, so I get -1/4. All right, 3 down, 2 to go. Okay, next. If x equals 1, then y equals -1/4 times 4 to the first power. That's -1/4 times 4. Now 4 is the same as 4/1. These 4's cancel, and we get the value -1. All right, one more left to go. If x equals 2, then y equals -1/4 times 4 to the second power, which is -1/4 times 16. 16 is the same as 16/1, and we can simplify this fraction. 16 divided by 4 is 4, which I write as 4/1. And now put it all together. So we've got -1 times 4/1, which is -4. All right, great. So we have all 5 of our points. The next thing we need is the location of the asymptote, if there even is one. All right, well, once again, our discussion of what's the base is going to come in very, very handy here. The base is 4, which means that the parent function for this equation is y equals 4 to the x power. Now we know that this is an exponential function, and we know that it has a horizontal asymptote sitting right on the x-axis. This is where the asymptote would be for this particular graph. And if I created a quick sketch, then this is what the graph would look like. Now, of all of the transformation types that we've studied in this class, the only one that affects the location of a horizontal asymptote would be a vertical shift. So if there's adding or subtracting outside far from x, that would change the location of this horizontal asymptote. Well, let's look at this over here. Do we see any adding or subtracting outside far from x? The answer is no. So this asymptote will be at the same place as this asymptote. So the x-axis is our asymptote. All right, so now that we have 5 points and an asymptote, all we have to do is put those 5 points in Alex, put the asymptote in Alex, and then tell Alex to connect those 5 dots together for us. All right, here we go. Let's create a graph here. All the y's are negative. So I'm going to use quadrants 3 and 4 for this particular graph. We got to go down to -4. So there's -4, which means there's -2, and there's -1. So 1 and 2, -1 and -2. And let's plot these points. Here we go. All right, so 2, -4, that would be here. 1, -1, that would be here. 0, -1/4. Well, that's a little tricky, but I think we can manage. -1/4 is equal to -0.25. So if you cut it in half and then in half again, that will tell you the location of that particular dot. 1/16. Oh, now we're really getting small. That's -0.0625. So I'm not gonna try to find the exact location of that. I know it's just a little bit below the x-axis. So I'm gonna draw my dot there. This one is even tinier, so that's gonna be right about there. And when I connect all of these dots together, this gives me my transformed exponential function. And then the asymptote stays right in the same place, which is on top of the x-axis. So all you have to do is put those 5 points into Alex, put that asymptote into Alex, click the button that connects the points together, and voila, you are done.